So are you able to see full screen, sir?
Yes, I can see your screen.
Thanks. So good morning to all. Coming to today's session, the topic is analyzing Bitcoin data via machine learning and evaluation. So machine learning is very important for Bitcoin price prediction. Because of that reason, I'm going to focus on what are the...
Sir, sorry.
Hello, sir.
Sorry to interrupt, sir. Your voice is little echo. It looks like you either you are sit in a big hall because
Yes, sir.
your
Yes,
voice is echo.
yeah. Is it not clear, sir?
It is echoing, sir. Actually,
Okay. 1 second. Otherwise, I'll try to change my place. Section, I call back now. So just a second, I'm trying to change the room.
fine. Maybe your if you can change your device, means the microphone, it will work. Maybe I think it will work.
1 second. Actually, I am using web browser, sir.
Okay.
I will check it setup. No, headphones only. Microphone, external mic. Everything is fine, sir.
External mic. So are you using your headphone or
Yes,
the computer?
No, headphones.
Okay. Your voice is little echo, like it is coming from your back. So it's like it's echoing.
Try to change the locations if possible.
Actually, just echo is the problem. Nothing wrong in your voice. It is perfectly coming, but some echo is there. So if participants are fine with that, so I don't have any problem.
I'm using web browser, sir. There is no issue, no?
No issue.
Participants, any issue with my voice?
Yes,
No, sir,
participants
it's
can
fine,
suggest.
sir.
No, sir, it is absolutely fine.
Yes, sir.
So no problem, sir. You can start, sir. No problem.
Okay, thanks.
Yeah. Okay.
So once again, good morning. So today I'm going to explain how to find the Bitcoin price by using machine learning models, and also we will see how to evaluate in detail so that we can find the significance of machine learning in Bitcoin prediction or Bitcoin analysis data. So before going to the agenda of today's session, so this is the motivation for the session, how to find Bitcoin market prediction via machine learning. This is published in elsewhere. Of course, these things we'll discuss in detail when you go for further slides. And this is the data set I'm going to use. in the entire session. Of course, other data sets also we have, but I will show the resources where you can download the data set, even latest information like up to yesterday's data. So I will show a website there you can download them data set if you are looking for any research publication or any research kind of work. I'll explain all these details. Don't worry about this data set. What is this high, low, open, close, what we are going to do with machine learning models or algorithms, and all those things we'll discuss in detail when we go for subsequent slides, so that we can understand the price prediction, how we are going to do by using machine learning models. And just our aim is to make a model or maybe machine learning model by using that how to predict the Bitcoin price. And this is a website. If you are looking for latest data, you can see here up to yesterday we have data. So what is the Bitcoin price, open, high, low, and volume of all those things, even change percentage, everything is available. Suppose if you want to download the latest data, you can go through this website investing.com, and from which you can download the Bitcoin data. There we have option cryptocurrency. If you click that, you can find various cryptocurrencies. There you can click Bitcoin, BTC. You can download this data. You have option also. You can see here download data. You can download this data set and you can use for your research work. Of course, I will show later how we are going to use for research also. Based on that, you can utilize for the Bitcoin price prediction by using machine learning models. And even one more thing I'm going to explain. So machine learning for financial product recommendation. This is also very, very interesting topic, how the machine learning recommendation system will work for banking, stock market, insurance, real estate, etc. in the finance domain. So that we'll discuss. It's very interesting because how we are getting recommendation of the movies or maybe YouTube videos, etc. Like that, how the recommendation system will help for recommending financial product in the finance field, that we will discuss when you come to the end of the session. So with this brief introduction means just like key points. Now I'll move to the agenda of today's session, what I'm going to explain in the rest of the time. First, we will see introduction of machine learning. So first, we should know what is machine learning. I'm not going to explain in detail machine learning. At least I will give briefly so that we'll get idea about machine learning, and is that we can apply for any applications. We will see that also. And what is Bitcoin? Just a definition, and with small history we will see. History means like who invented and what are the advantages of Bitcoin, that we can call it as BTC. So that we will see. No, I'm not going to take much time for this type of theoretical aspect. Just I'll give briefly. After that, we'll move to the mathematical aspects for in machine learning. So regression analysis, that is the main agenda. So by using regression analysis, how we are going to find the Bitcoin price prediction. I will show some of the research publications under this concept. Of course, I have shown already one publication in Elsevier. Like that, we have so many other publications also available that we can use for reference for doing research work, or if you want to do any publications. And intuition of linear regression. So here we should know what is regression exactly, the concept. For that I will explain the intuition, little bit mathematics, there is no machine learning. So that's why here some mathematical intuition I will explain. So based on that, we will see how we are going to find the Bitcoin price prediction or Bitcoin price estimation. And also case study, we will see by using a regression model, how the Bitcoin price prediction case study, what I have shown in the data set previous slides. So by using that data set, how we are going to find the regression model, followed by how we are going to find the prediction. Of course, evaluation measures also we are going to discuss, because whenever if I go for any machine learning model without evaluation, it is difficult to decide which model is the best fit for the given data. So for example, if we take Bitcoin price prediction, there are so many models are available. So regression, linear regression, multi-regression, and LSTM model, deep learning model, so many models are available. So which model is the best for the given data? So for that, we have to go for evaluation. So based on that evaluation only, we can decide this is the best model. Hence, we can deploy to the application for predicting the Bitcoin prices in future. Because of that reason, evaluation plays a vital role. That also I'll explain in detail with examples. And also I will show artificial intelligence in finance by using recommender system. So that I have shown previously how the recommendation system plays a vital role in finance, like banking sector, real estate, etc. That we will discuss with small examples. You can understand. So with this brief agenda, I'll move to the machine learning. So what is machine learning? So whenever if I take human being, we can learn based on the experiences. What about mission? Is it possible to learn mission? Yes, mission also can learn. So based on the data with the help of machine learning model. So here data is very important. So plus we required machine learning model. Based on that, mission also can learn. Without data, nothing to do with machine learning. That's why data set what I have shown investing.com website, there we can download the Bitcoin data set, and after that we can apply machine learning models to the Bitcoin price prediction. So that means here data is very, very important. Without data, because now we are in big data era, so everywhere data plays a vital role. So without data, nothing to do with machine learning models or deep learning models, etc. That's why data is very, very important. So that's why, so machine learning is a tool which will extract our knowledge from the data. Based on that, we can go for prediction or classification. So, but data is very, very important. Data is the fuel that drives the machine learning engine. So what is the meaning of extracting knowledge, or we can call it as insights of data, all those things, so that we can see in detail when we go to the further slides. So what is the meaning of insights or extracting knowledge from the data means? So for example, let us assume we have day. Let us assume day means X, I am assuming. Y is nothing but Bitcoin price, let us assume. So day 1, day 2, day 3, let us assume some Bitcoin prices, let us assume. Okay. 1 second. Okay. Okay. So Y indicates the Bitcoin price in terms of dollars or maybe Indian rupees. That's depends on the application. So here I'm taking Y value 4, let us assume 5, let us assume 7. So this is the data. So X value, Y value, X is nothing but day, just for understanding, or maybe you can take time also, maybe 9 o'clock, what is the Bitcoin price, 10 o'clock, what is the Bitcoin price, like that, depends on the situation. I'm taking day and BTC price. So this is, you can take it as a BTC, and this we can take it as a day. Let us assume. So why I'm giving this example, just for understanding the definition of machine learning, what is the insights of data, extracting meaningful data from the based on that, how we are going to predict. Now this data is available. Now by use, this is called, we can call it as a historical data, we can call it as a data, or we can call it as a historical data. By using this historical data, we have to make a regression model, we have to make a machine learning model. It may be regression, or it may be a deep learning, or it may be LSTM, whatever it may be. So let us assume I'm assuming regression model. So I made a regression model based on that data. Let us assume, so 2 plus X, let us assume 2 plus 3X, something I'm assuming, let us assume 2 plus 3X. So this is the model. That means, so after training this data, so I can make a model that we can call it as a linear regression model here. Now this is the, we are extracting knowledge from the data, insights of the data. By using that, I made a model. Now what is the use of this? Now second point. So let us assume I want to find what is the Bitcoin price day 4, and what is the Bitcoin price in day 5. What is the Bitcoin price day 6? So for that, what we are going to do is substitute X in place of, X equal to 4. So Y equal to 2 plus 3 into 4, 12 plus 4, 14. So that means, so this is the Bitcoin value on day 4. In similar fashion, this value we have, this is question mark. So similarly, substitute X equal to 5. Similarly, these are all question mark. Substitute X equal to 6. So substitute X equal to 6. So that we can find the Bitcoin prediction of 4th day, 5th day, 6th day. So based on that, we can go for further step. Maybe whether we have to keep your coin as it is, or we want to sell, that we can take. That is the main decision making is left to the customer or user. But my aim is to find the Bitcoin price prediction. So here what I explained, definition of machine learning. So machine learning is model is to extract the knowledge from the data, or pattern from the data, or insights of the data. Meaning is this one. So this is the pattern from the data, or insights of the data. And what is next step in the definition I given? By using that, we can go for prediction or forecasting. Classification, leave it here, because that when you go for healthcare application, all those things there we can apply. But here we are going to prediction by using this model. For that, what we have to substitute X equal to 4. substitute x equal to 5, substitute x equal to 6, so that we can find a Bitcoin price on day 4, on day 5, on day 6. So this is a basic idea in machine learning. So we are going to go for weather forecasting or Bitcoin forecasting or prediction, or maybe medical diagnosis. So based on the symptoms of the patient, I have to decide whether the person having COVID-19 or not. So this is the basic idea of machine learning. So that is the thing what I explained in the definition. So it is a tool to extract knowledge or pattern from the data. That means what I done in the data, what I have considered simple data, I made a model y equal to 2 plus 3x, and based on that what I done, I made a prediction about the x value, and by using that we can go for decision making. I think it's clear definition. Why I'm giving examples? So because most of the participants I think are non-computer science, so that's why I'm giving these many examples. Otherwise I can move directly also. So this is the simple definition. We have to we are looking for insights of the data or extract knowledge from the data. By using that we can make a model. This is nothing but model here. So this is nothing but model, and by using this model we can go for forecasting or prediction. So what does it mean, forecasting or prediction? At day 4 what is the Bitcoin price? At day 5 what is the weather forecasting? At day 6 what is the weather forecasting? Like that depends on the application, but the concept is same. You can go for any application. It may be weather forecasting, whether you can go for Bitcoin price prediction, or whether you can go for number of COVID cases prediction, because we can predict number of COVID cases tomorrow based on the data available up to today. That is called by using regression model or any LSTM model. We have so many models. So I'm sticking to here regression model, but we can apply other models also, depends on the application. So this is the basic idea and definition of machine learning. I think hope it's clear. If you understood this definition, rest of the slides you can understand very easily, because same thing way I'm going to explain, but only thing is I'm going to involve more mathematics when we come to the further slides. So now how machine learning is different from traditional programming. In traditional programming, what we are going to do is, suppose let us assume I have to find sum of two numbers. I hope most of them know C programming. So let us assume I have to find sum of two numbers. Let us assume C equal to A plus B. So this is the equation. I want to find sum of two numbers. So first we have to write a program, A, C or C++, whatever it may be. After writing program, first this is the step. We have to write a program, declare variable, main function, declare variables, take values from the keyboard and evaluate, print the C value like that. After that, we have to give the data, that is called input data. Input data is, let us assume A equal to 5, B equal to 4. What is the output? Will get 9. So this is called traditional programming. If you take C, C++, etc., these are all traditional programming. So here we have to write a program. We have to give input so that we'll get output. That is 9. Now, how it is different from machine learning? So now come to the machine learning. In machine learning, what happens? Data output is input to the system. Based on that, we can make a program. I think it's difficult to understand what does it mean. So here, if we take clearly, what does it mean? Suppose if we take, let us assume X, just now I explained Y. So 1, 2, 5, 6. This is the data available. So X is a input, Y is output, or we can call it as a response. A response variable or target variable. Now X also we have to give, Y also we have to give as an input to the system. Based on that, it will make a model. Let us assume 3 plus 2 regression model. Let us assume, just now we discussed. And by using this model, we are going to go for future value or prediction. So that is the meaning here. So data and output, that is the input to the system. It will make a program. Program is nothing but algorithm or model. By using that, we are going to evaluate the future value. So that is the difference between traditional programming and machine learning. So if we take one more example for healthcare application, so here this is input. So this is personal health record. So symptoms of the patient is nothing but input, and output also we are giving as input to the system. In output means what is the COVID, positive or negative, whether the patient having positive or negative. Up to today, this data is available. This data we have to give to the system, and by using that, it will make a model. Let us assume some machine learning model. So like this. So X is input, X comma Y are input, then it will make a model f of X, and whenever new patient coming for testing, we can call it as active patient. We can give X value, that means all the futures, X1, X2, so on, Xn. Then we can predict whether the person having COVID positive or not. Let us assume the person having COVID positive. So that is the meaning of definition of machine learning. We are giving input as well as output to the system. It will make a model or algorithm. By using that, we are finding the future value or classification, whatever it may be, depends on the application. Here I'm doing classification, whatever new patient the symptoms, if I consider, based on that I can decide whether the person having positive or negative. How it possible? Based on the previous data, training data. So this is the meaning of machine learning, what we discussed in the traditional programming and machine learning. Now, when you come to the machine learning model, we have data and we have to make training data, tested data. Let us assume I have a Bitcoin data that is extracted from investing.com website. I have shown already. So let us assume I have 10,000 records. That means 10,000 rows in the Excel sheet. So out of which I have to go for training data. Let us assume 80% or 70%. This 80% I have to consider training data. Remaining 20% I can go for testing. When you make training, so it will produce a model. Just now I explain one example of linear. Let us assume the model looks like this: 2 plus 4x. Let us assume linear regression. By using this model, we have to go for tested data. We have to give this input to the tested data. Based on that, we can evaluate. So whether for example, in tested data, actual Bitcoin price is $4 and predicted Bitcoin price is $3.9. So this is the meaning. So we know output in the tested data, but my model, whether it will predict the accurate value or not. 4 is the actual Bitcoin price, $4, but my model predicted 3.9. It's very close. So that's why acceptable. Suppose still if you are looking for more accuracy, you can apply one more regression model or one more machine learning model. Maybe there you will get, let us assume, 4.98. Then this is much better than previous one. So like that, we can test for various models for the tested data and finally evaluate accuracy. Based on that, we can decide which model is the best and that we can deploy to the application. So that's why test data, training data, and we have to evaluate, that is called accuracy. Based on that best accuracy regression model or maybe machine learning model, we can deploy to the application for Bitcoin price prediction. So that's why whatever data set we have to consider, we can't directly give entire data for training. We have to split 70-30 or 80-20, depends on your convenience. And after that, we have to make a model. By using that model, we have to evaluate, and based on the accuracy, we can deploy to the application. If the accuracy is, let us assume, 99.12 or 99.99, then it is one of the best accuracy of the model, then we can deploy to the application. And what are the applications of machine learning? We have various applications like image recognition, traffic prediction, recommendation, self-driving cars, email spam, like that. But here we are focusing this application. I am highlighting stock market trading, in which we are looking for Bitcoin prediction. Of course, in stock market trading or stock market prediction, so many things we have under this. So under which only Bitcoin price prediction, all those things comes to the picture. Of course, rest of, even this also we are going to touch recommendation system for finance field, how the recommendation system plays a vital role for recommending the policies or maybe banking, what we can call it as a schemes to the customers. So that's why recommendation also very, very important in finance field also. I will show some of the references, publications, and based on that, how the recommendation system plays a vital role for finance. So at the end of the session, I will go to that also. And mainly we are focusing on Bitcoin price prediction. So we have, that's why machine learning comes to the picture now. We have huge number of applications. That's why there is a huge demand for machine learning experts or data scientists. So by 2025, around 11 million people required for this data science application problem solution. That means this much requirement is there in data scientists. Of course, there we have various categories are there. That is another issue. And here we are going to go for classification classification is a very simple thing. Suppose we have students, let us assume 60 students. These are the group of students. Out of 60, let us assume 20 students are passed, 40 students are failed, or maybe vice versa. So this is one classification. This is pass, this is fail. So this is one class pass, and this is one class fail. This is called binary classification. Suppose if you are looking for categorical classification, in which how it looks like, so 30 students are a distinction, I am assuming, and 20 students are, let us assume, first class, and 5 students are second class, and 5 more students are failed students. So this is the categorical classification. So based on the categories here, first class, second class, distinction, failed, like that I categorized. Based on that, we can call it as a categorical classification. And this is binary classification. Binary means either true or false. That's why we can call it as a binary. So here we have only binary classification. This is called categorical classification. So in supervised learning, what happens? So we have various types: supervised, unsupervised, semi-supervised, reinforcement, all those things. But we are going to focus on supervised learning. What is the meaning of supervised learning means? So for example, if we are talking about Bitcoin, so let us assume starting price of the Bitcoin of today. Let us assume start. Let us assume what is the high price, what is the low price, what is the closing price. So closing price is nothing but our target variable, that is called a dependent variable, or that what we are looking here. So here what we have to do, these values are given. So 5, let us assume 6, 7, 8. So this closing price is nothing but labeled data, because ultimately we are looking for Bitcoin price at the end of the day, that is called closing price. We are looking for closing price. Closing price is nothing but Bitcoin prediction. Suppose if closing is not available, then this is not supervised. This is called unsupervised learning. Suppose closing data is available, we can call it as supervised learning. That means here x1, x2, x3, y. So y depends on x3, x2, x1. So this is called supervised learning. Y is nothing but label, or we can call it as a class, or we can call it as an output. So that means in supervised learning, we have a data as well as label, or we can call it as a class, or we can call it as a output or dependent variable in the case of regression model. So that is called supervised. Suppose if I remove closing price, that is called unsupervised. Suppose if I include some closing prices, some non-closing prices, some data having closing prices, some data not having any closing price, let us assume not applicable or maybe nil, then that is called semi-supervised. It's a combination of supervised as well as unsupervised data. So there is the meaning supervised. That means we have a teacher as a student, that is called supervised, because he is giving supervision to the student. And unsupervised means there is no labeled data. That means independent study. So closing price of the Bitcoin is not available, but still we are looking for closing price. It's a little bit complicated issue. So that is called unsupervised. So teacher, how it possible to study properly? Like that, so, and if we have a teacher, we can study properly. That's called supervised. If you have a closing price up to yesterday of Bitcoin, I can predict easily today what is the closing Bitcoin, or Bitcoin price prediction I can do easily. That's why. So we are focusing only for supervised learning. That means up to yesterday, I have data of Bitcoin. That means low, high, starting price. Based on that, closing price also available. So based on that, today I'm looking what is the closing price of the Bitcoin. So the data looks like this. So here you can see x1, x2. This is the labeled data. That's why we can call it as supervised learning. And unsupervised learning, we don't have any teacher here. That is called no label or no output. So this is called unsupervised learning model. And semi-supervised means it's a combination of both supervised and semi-supervised. Sorry, unsupervised. Some data having labels, some data having not labels. That means it's a labeled as well as unlabeled data is nothing but semi-supervised learning model. But we are going to focus in today's session, so supervised learning models. We are not going to focus for without labeled data, and it's a combination. That's why unsupervised out of scope, and semi-supervised also out of scope of our today's session. So we are going to focus only for supervised learning model. By using that, how we are going to look for Bitcoin price prediction. So that this is the basic idea. So in supervised learning, we have a data, labeled data, and we have to make a model. For example, if you take regression model, we have Bitcoin prices up to yesterday, and based on that, I can go for regression model 2 plus 3x. This is the model. By using that, I can identify what is the Bitcoin prediction today. That means closing price today, or maybe tomorrow, what is the closing price. Like that, we can identify. That is the model what we are looking based on the historical data. But here we have labeled data. Labeled data means we have closing price of each day up to yesterday available. When you come to the semi-supervised, labeled data and some unlabeled data, based on that we can make a model. And unlabeled data, that is unsupervised learning. Here also we have some data having labels, some of course all the data having no label. That's why that is unlabeled. That's here also we can make a model, but we are not going to focus these two things. We are going to focus for only labeled data. So that I already explained, machine learning, we have supervised, unsupervised reinforcement. Of course, reinforcement, unsupervised not required here. We are going to focus on supervised learning for Bitcoin prediction, in which we are going to focus regression. So by using regression, we are going to predict the Bitcoin price, that is called closing price. So maybe depends on the data set. If we have, let us assume opening price and closing price, then we can go for linear regression model. Suppose if we have opening price and high price and low price, based on that, how to find closing price, that is the end of the day. So that is called multilinear regression we are going to apply. So depends on the data set in which how many number of independent variable. Based on that, we can choose the model. It may be linear regression model or it may be linear regression model. That we will see both cases in the subsequent slides for Bitcoin prediction, price prediction. So this I already explained. So regression means we have x1, x2. We are looking for price, that is called Bitcoin price. And when you come to the classification, whenever if I collect some information from the patient, let us assume symptoms, I have to classify whether the person having COVID-19 or not, or maybe whether the person having heart disease or not. That is called classification. So we have to collect symptoms from the patient like fever, headache, etc. COVID positive or negative. That is called classification. Regression means we are going to predict the value, that is called continuous value, that is called a numeric value. So maybe the Bitcoin price prediction is $100 or $200 or maybe $1,000, like that. Depends on the, we can go for prediction of the price. That is the regression. So that difference classification, we are looking for either binary classification or categorical classification. In regression, the output is a continuous value or numeric value. So here I give an example for price prediction of the house. So square feet, number of bedrooms, number of bathrooms, based on that, what is the house prediction? So when you come to the square feet available, number of bedrooms, number of bathrooms, what is the price, house price? This we have to predict. How it possible? We have to train this data and we have to extract insights of the data. Based on that, we can make a model in which we have to substitute number of bedrooms, number of bathrooms and square feet of the house. We will get the price of the house prediction. So this is the very simple way to go for prediction. Same thing we are going to apply for our Bitcoin price prediction also. So this is a overview. So we have historical data. I'm telling same thing from first slide. Historical data means Bitcoin data up to yesterday, and we have to apply predictive algorithms. So many predictive algorithms we have, out of which we are focusing on regression. Of course, still we have more accurate algorithms also available. Just I'm giving the brief idea. Based on that, we can go for further algorithms for applying to the Bitcoin price prediction. And based on that, we can make a model. So finally, first step is, our aim is to make a model. Model is nothing but algorithm, or maybe we can call it as a program. By using this program, we have to go for new data. Let us assume today I know what is the starting price of the Bitcoin and high price of the Bitcoin and low price of the Bitcoin. Based on that, this is the new data. Based on that, we can apply this model to this new data and I can go for prediction. So the Bitcoin price prediction is, let us assume $10K or maybe 20K US dollars. Like that, we can go for prediction. That means model is important, and based on this model, whatever new data, maybe today's data or tomorrow's data, whatever it depends on the application, we can go for prediction. So this is the predictive analytics what we are going to perform for the price, Bitcoin price prediction. Now, so far we completed just a brief idea about machine learning. What is the definition of machine learning, and what are the applications? Discussed what is supervised and unsupervised with clearly examples. Now we will see the second part, that is Bitcoin. So now why I'm telling, we know machine learning, we should know Bitcoin, and how we are going to correlate both. So that's the main thing here. So actually it's very simple nowadays. Bitcoin word is like buzzword. So here it's very simple thing. Bitcoin is a virtual money, or we can call it as a digital currency. So the advantage is, so we can Bitcoin are transferred directly from person to person via internet without going through the bank. That means that's why we can call it as a Bitcoin is a decentralized currency. Suppose if we go for centralized currency, what we have to do here? What does it mean? So let us assume I am one person and my friend is there. Here bank is there. Let us assume this is the bank. This is the centralized. So whenever if I want to transfer money, it will go through bank only. So this is called centralized one. But when you come to the decentralized, that is called Bitcoin, that is called virtual money or digital money or cryptocurrency, this third person, that means this bank is not come to the picture. So this we are going to remove. Directly we can transfer money to this one. That is called virtual money. So of course we can use this virtual money for to buy the products or to buy the shop to go for shopping, etc. Also, but not everywhere. Some of the countries this one banned, but most of the countries are using this virtual currency. So of course so many applications are there, as I mean advantage as well as drawbacks also. But obviously in future there is a huge demand for this Bitcoin. So that's why here the advantage this one is there is no third person, or we can call it as a here centralized bank. So but when you come to the general transferation, obviously one middle person is there. So that is the one thing here. So actually this is invented in 2008. So by an unknown person or group of people, that is called Satoshi Nakamoto. So you can see here Satoshi Nakatomi. So this is not exact name. We can call it as group of people. Some references they mentioned as name of the person. Some references they mentioned this is a name of the group of people invented the Bitcoin in 2008. Of course, now it comes to the picture. Most of the countries they are using this Bitcoin, and we have huge applications also because of this Bitcoin decentralization, as well as there is no fees. Suppose if you want to transfer money, obviously we have some fees. The bank will deduct automatically, depends on the money how much we are transferring from one person to other person. But when come to the Bitcoin, these charges are very, very less. So that is also one of the advantages. These are all like digital coins. We can call it as a virtual money. So we can use for this completely virtual and online version of cash. We can call it as a, we can use to buy products and other services. We can use this one. And how it will work means here there are so many we can call it as exchange traders are available, and if even we can download apps. So many apps are available like Coin DCX, WAZ, IRX, JebPay, like that. So many apps also available. You can download and you can use this Bitcoin. What we can call it as a selling, or maybe you can buy also. So that's why we have so many apps also. So we can download these apps and we can download this digital wallet, and we can go for further steps. Now we are huge number of applications. Sorry, we can call it as advantages or benefits like payment independence. I already said we can directly transfer from one person to other person. There is no centralization, because if you go for centralization, bank is there between me and my friend. So if you go for Bitcoin transfer, there is no bank here. That is a decentralization. So, and security is there, transparency is there, low processing fees, because there is no much processing fees when compared to the bank. So that's why it's a very one of the benefit for this. So here we can see all the benefits. This is just like theoretical aspects. Now the data set looks like this. What we are going to apply here, you can see here date and opening price. So of course details also I will show in detail. Open price, high price, low price, closing price. Here don't get confusion. So this is one variable, open is one variable x1, high is one variable x2, low is one variable x3, closing is nothing but what we are looking, that is called y variable. We are looking for the prediction of closing, that is called closing price of the Bitcoin, that is called y value. So that means, so we have x1, x2, x3 according to this data set. So by using these three, we are looking for y value. This is the closing price, or we can call it as a Bitcoin price. Sometimes open price is available, open Bitcoin price is available, but there is no high low. In that case, just one variable x. By using that, we are looking for y value. That means we have to make a model. After that, we are looking for y value. Y is nothing but Bitcoin price prediction, or we can call it as a close price. And you can see the data. This is 2013. But if you want latest data, I will show the data set once again. So by using this, we can go for this USD prices Bitcoin. So $110 like that, $98. So if you are looking for latest data, I already said you can go through this website investing.com, in which you can click the cryptocurrency. There you can go for Bitcoin. Of course, lightweight coin. So many other things also there. There are so many other cryptocurrencies are available, but you can click BTC and you can find that download this data set. Here you can say up to yesterday we have data. So March 10th, 2022, March 9, 2022, what is the Bitcoin price and what is open, what is high, what is low, and volume. Volume is like a number of transactions of that Bitcoin, and what is the change. So here price is nothing but closing price. So this we are looking here, open, high, low. So based on these parameters, or we can call it as independent futures, we are looking for price of the Bitcoin. In the data set here, you can see this close is nothing but price of the Bitcoin. So that you can find in this website also. You can download is with free of cost only. Only thing is without login through mail only. You can see here sign in the top rightmost corner. If you click this, maybe you can enter your mail ID, or if you already having a Gmail, so directly we can join and you can download this data set for your work. This is yesterday data. So this I downloaded today morning for the sake of section. So here you can see you can choose the date also, from which date to which date you want. Here you can see here, this is, that's why I said already, this is historical data. Here you can see I have selected 2/10/2022, 3/10/2020. That means 1 month data I have selected here. Just a second. Just a second, I have to get water. Now I'll come to the next one. So how to find the Bitcoin prediction by using regression analysis. We are going to focus on regression analysis. I will show some of the reference papers also. You can go through that papers and you can find so many other regression models also. So basically the regression analysis deals with the relation between independent variable and dependent variable. So independent variable is nothing but predictors. Dependent variable is nothing but target variable or response variable. So I have shown already, if you take, let us assume x, y is independent, dependent variable, x is independent variable. So that means the value of y depends on value of x. That's why we can call it as a y is a dependent variable, x is independent variable. Or we can call it as a y is a response variable, x is called predictor. Suppose if we have more than one independent variable, it looks like this: x1, x2, let us assume x3 and y. So in this case, number of independent variables is 3 and dependent variable is y. So this is a basic definition. It will make relation between dependent variable and independent. It's very useful for forecasting and prediction, etc. Especially if you go for price prediction, salary prediction, weight prediction. For that, we can go for these regression models in the machine learning. So we have various applications of regression analysis, like house price prediction and how to predict exam score, and also economic growth, and also housing sales and product price we can predict, and also Bitcoin price we can predict, etc. Now we have various type of regression models. By using that, we are looking for Bitcoin price prediction. So here first one is a linear regression model. So in linear regression model, number of independent variables is only one. The data looks like this. So x, y, then we can apply linear regression because only one independent variable, one dependent variable. Obviously, always we have one dependent variable or one response variable only. So that is called linear regression model. If we go for polynomial regression, so here you can see degree is more than one. Linear means degree should be one. Polynomial means more than one. So like 1, 2, 3, so on. Yeah. Like you can see x power 1, x square, x cubed, x power n. This is called polynomial regression. X square, so on. If we go for multi-regression model, number of independent variables is more than one. So the data looks like this. So x1, x2, x3, so on, xn and y. So in polynomial regression, independent variable is one only, but the model looks like a polynomial. That's why we can call it as a polynomial. Of course, we are not going to use this our Bitcoin prediction. We are going to focus for linear regression, and we are going to focus for multi-regression model. Why we are going to focus multi-regression model? Because I have shown already that data set. There we have low price, high price, and starting price of the Bitcoin. Based on that, I'm looking for closing price, that is called by value. That is called, we can call it as a dependent variable, in which we are going to apply multi-regression model or multiple regression model. Similarly, we have logarithmic regression and also power regression. Logarithmic regression means we are applying a logarithm here, natural logarithm, and power regression means we are using power function, and we have exponential function we are using. That's why we can call it as a exponential regression. Like that, we have various regression models. Depends on the data set we can apply. And suppose if more than one model is suitable for the given data set, we have to apply. After that, we have to evaluate. Then we can decide which model is the best for the given data set. So that's why evaluation is very, very important. So based on the performance, we can decide this model is the best. Based on that, we can deploy to the application. Now we will see intuition of linear regression. So once if you understood the intuition of linear regression, based on that entire regression depends on, or based on that we can implement. So that's why at least we should know one regression model, exactly what is happening beyond this. That is called mathematical intuition. Of course, I can do directly formula and you can apply for the given data set, you will get output. That's not a big issue. That's not a big task. But we should know what is exactly happening beyond that. That is the important thing when you are looking for any research kind of thing. So that's why first we will see what is the intuition of linear regression, and after that we will see how we are going to apply linear regression for the given Bitcoin price prediction, or by using that if we have multiple variables, then how multiple regression will apply to the Bitcoin price prediction. But the concept is same. What we are going to apply for the linear regression intuition, same thing applicable for other regression models also.
Hello, sir. Hello.
Hello, madam.
Sir, I have one doubt. May I?
Tell me, madam.
Sir, let's say in the independent variables, the variable is return on the market, then return on the market square, and the absolute return on the market. There are three variables are there as a dependent. Then what models we can say? Is it multiple regressions or that polynomial?
No, let us assume your data looks like this: x1, x2, x3. Let us assume y. Am I right, madam?
But the variable is same. One of the time we are making the square of that variable, and another time I am keeping the absolute of that value.
No, but here that in the dependent variable should be always one, madam. Here, this is called response variable or target variable. It should be always one. But here, number of independent variables, one means we can go for linear or maybe polynomial or logarithmic. When you have multiple variables, we can go for multiple regression, madam.
Okay, fine.
Suppose if you have one independent variable, what we said, let us assume xy, you can apply linear or logarithmic or exponential or polynomial, but based on the accuracy, you can deploy to the application.
Okay, okay.
Is
See,
it
my
clear,
mean to say, sir, dependent variable is one. I have three independent variables, but
yes,
the variable value is supposed to be changed. Let's say the return on the market, let's say the Sensex. Second time I am taking the square of the Sensex, and third time I am taking the absolute of the same.
No, here what we are going to do is these variables are independent. For example, if we take 5, here if we take 25, this is this what you are asking,
yes,
right?
Yes.
This in this case we can say x2 is depends on x1. This we are not going to consider. The assumption is these variables are independent in nature.
Okay.
Suppose if we take here x1 is 1, here 1, x1 is let us assume 4, here 16, according to your doubt. Am I right, madam?
Yes, sir.
Yeah. In this case, x2, x1 are dependent. So x2 no need to consider only. No need to comes to the picture because both are same variables only.
Fine. Got it, sir. Yeah. Thank you so much.
If you have such type of variables, you can ignore in the pre-processing step, madam. Because when you are applying any model, we have pre-processing step. There we have to look for any values are missing or any this type of issues are there. We'll try to sort out. Then we can apply model. Suppose if you apply as it is, you won't get more accurate results. That's the problem.
Yeah. Yes, sir.
Got it,
sir. Yeah. Thank you, sir. Yeah, got it.
So now come to the intuition of regression model. So I already said linear regression means we have only one independent variable like y equal to mx plus v, or maybe y equal to a plus bx. It should be linear function. and very simple function. And multiple means more than one independent variables, x1, x2, so on. We can call it as independent means one variable should not depend on other variable. So the meaning is like this. Suppose if we take x1, so x2 is not x1, x2 independent means there is no relation. Suppose x2, x1 are not independent means x2 may be like this. It looks like x1 square, or maybe 2x1, or maybe 5x1, or maybe 5x cubed, 5x, like this. So this is, we can call it as a dependence. So in this case, x2 we have to eliminate. We have to ignore in the pre-processing step for further processing. So that is the main thing we have. That's why we can call it as a all x1, x2, so on, xn are independent. If you consider, the problem is you won't get much accurate results. That is the problem. Now here we have scattered plot or scattered diagram. Here this is very important for making a regression model. So let us assume if we have age and pages. So let us assume we have to make it as x-axis age and y-axis page. Just we have to make a dots. So when x equal to 14, if you want here, I'll write clearly. Sorry, yeah. So here let us assume, here I'm drawing x value, let us assume a student roll number, y value is marks. So roll number 1, student marks is, let us assume 30. So here I want to make a dot. Roll number 2, student marks is 50. Let us assume corresponding to that we can make a dot. So just we have to plot the data points. This we can call it as a data point. These dots we can call it as a data samples or data points or sample points. But each corresponding x value we have to write y value dot. So when x equal to 10, y value 40, you can put dot. So just we have to make a plot. So this is called scatter plot or scatter graph or scatter diagram. Now the data points looks like this. You can see here right corner. So x value, y value, corresponding to each x value, y value we have to plot. So these are all y values corresponding to x value. We can call it as a data points or as data samples of the given data set. So you can see here this is the data set, and this data set we have to make it as a scatter diagram. There these dots, or we can call it as a plots, are nothing but the data points or sample data samples. Now the question is how to find the regression model. So we have to make a regression model. So linear regression, let us assume here we are talking linear regression. So like this we have to find one regression model. Let us assume the regression model looks like, so y equal to 2 plus 3x. So in this case, so here y is nothing but 2 plus 3x. If some data point is available, let's assume 10. So if I am looking for what is the value of y corresponding to x10, then substitute this x value, we can find. That means it will touch this point, regression line. So based on that we can predict. Now the question is how to find this line. Here I am giving one regression line. So maybe one participant will assume like this, one participant will assume like this, one more participant will assume like this, one more participant will assume, or maybe I will assume like this. So we have infinite number of regression lines. Which line is the best line, or which line is the best fit line for the given data set? That is the big question here. So if I know directly how this is the regression line, whatever if I draw that is the regression line, that is meaningless. Then you won't get accurate results. Sometimes you'll get worst results. So at that time, how can you deploy to the application? Because of that reason, always try to make best fit regression line. So based on that, we can go for prediction or forecasting of Bitcoin, or maybe weather forecasting. So here what we are going to do is here, so let us assume, so this is the x value and y value. Suppose the data points are like this. This is one data point, this is one data point, this is one data point, this is one data point. So suppose if I find regression line like this, what happens? These data points are not touching this regression line. The regression line is 2 plus 3x. So what does it mean? I can't go for forecasting for new y value, because these actual data points and this new, the regression line is nowhere connected. So this is worst regression line. I can go for this is nowhere related. Suppose if I go for regression model like this, so you can see here almost all this looks like, let us assume y equal to 3 plus 4x. Let us just for understanding, I'm assuming. So here you can see the data points which are close to the regression line. So meaning is actual data point is 5, the estimated data point is 4.9. Actual data point is 6, the estimated data point is 5.98. So both are very close. That means the predicted regression model giving almost close to the actual data point, then we can say this is the best fit regression line. So that means our aim is to find the regression line which is very close to the data points. Regression line means function y equal to a plus bx function, and by using that we can go for prediction of future value. So always make sure that by finding the regression model, it should be very close to the given data points. So based on that we can get more accurate results. So here what we are going to do is, let us assume, so this is the actual data point, my estimated data point is here. Let us assume 0.9 something. So this is the actual data point, but this is the estimated data point. This is the actual data point. This is the estimated data point. This is the actual data point. This is the estimated data point. That means we have slight difference. That is called error. So whatever, if we take difference, this is called error, or we can call it as a residue. So I will come to the point why I'm explaining this one. This is called error. What does it mean? So actual data point is 5, estimated data point is 4.5. What is the error, or we can call it as a residue? 0.5. So that is the meaning here. So here you can see this is called, this difference is residue. Always make sure that this residue should be minimum. Suppose 5, 4.5, 0.5 is the error. Maybe is it possible to make 5, 4.9? If we take, what is the residue? 0.1. 4.9 is very close to 5. So that's why we can go for, this is the best fit regression line. Always make sure that the error should be always minimum. And here, and one more problem is, suppose if we take here, the error is, let us assume 0.2. Here error is minus 0.1. Here error is negative, because meaning is negative means here actual data point is 5. The predicted data point is 5.6. Then what is the error? Minus 0.6. So that is the meaning, negative error. So this is also negative error, and this is positive error. This is negative error. So some errors are positive, some errors are negative. Always make sure that when you make sum of all the errors, it should be minimum. For that, what I'm trying to do is this, I'm going to square. So let us assume this is D1, this is difference, that means error. This is D2, D1 square, D2 square, D3 square, D4 square. Why I'm squaring? Suppose if we have negative error also, we can make positive. I can see how much error we have. Otherwise, what happens if we have negative error, positive error, if we add, it becomes 0. It does not mean the regression line is the best fit. Because of that reason, make sure that the sum of squares of residues or errors should be minimum. Now, always we have to make a square of these errors and look for minimum. So here, this is the meaning. You can see here, we calculated the residue D1, D2, D3, and we have to make a square. Why means here we have negative error, here we have positive error, here we have negative error, we have positive error. So we want to make it as everything a common platform. So that's why I want to make a square. If you are not make a square, then what happens? Sometimes you will get sum of errors is 0. It does not mean it is a best fit regression line. That's why always we have to make residue sum of square. That is called RSS should be always minimum. If it is minimum, then that is the best fit regression line. Now you can see here, for example, one data I have, and I applied 3 regression models. This is one regression model, let us assume L1. This is one regression model L2. This is one regression model L3. But all these 3 models I applied to the same data set. Let us assume same Bitcoin price prediction data set. Here, residue sum of squares is 28. That means the sum of squares of error is 28. Here 22, here 24. Which is the minimum error? 22 is the minimum. Therefore, L2 model is the best fit model. That means the sum of squares of error is minimum. Hence, we can say this is the best fit regression line. Second one. So this we can ignore. This we can consider. This we can ignore. That's why finally L2 is the best regression model. By means here I am getting very less error. That means the data points which are very close to my regression model. Based on that, I can go for exact or maybe more accurate Bitcoin price prediction in the future. Otherwise, if I want to go for L1 model, I am not able to find Bitcoin price prediction most accurately. Or if I consider L3, I can't go for Bitcoin price prediction more accurately like L2. Because of that reason, L2 is the best fit regression model. Why means it will give the minimum error. So now what is the concept? Always make sure that we have to find regression model which will give the minimum error. So this is a basic intuition or basic idea beyond this regression model. And based on that, we have some small mathematics. Of course, if you are computer science and mathematics, you can understand easily. But if you are other non-computer science or non-mathematics, leave it. No need to worry about this one. We can go for formulas also. Here, what is the reason of this mathematics we are applying? So just now we explained we have to minimize the error. For that, we have to use partial derivatives. So how to minimize the error? So sum of squares error should be minimum. So for that, we have to find the regression model. So for finding regression model, we should know what is A value, B value. Because of that reason, we have to use these partial derivatives, minimize the concept. So that means whenever if you want to make a function is minimum, dou u by dou a. Here A is one parameter, B is one parameter. A is y-intercept and B is the slope. So dou u by dou a. After using partial derivatives, we'll get one equation. And dou u by dou b equal to 0. After using partial derivatives, we'll get one more equation. By solving these, you will get B value. covariance of x, y by. Here we require some mathematical and statistical concept. Directly I'm writing b value. After simplification only I'm writing, and b value is covariance x, y by v of x, or maybe summation x, summation y, like this. And by using b value we can find a value as. So finally, whatever regression model we are considering, y equal to a plus bx, a value we can estimate by using this formula, and b value we can estimate by using this formula. Based on that we can find the best fit regression model. So what is the concept we applied? The sum of squares of error should be minimum, otherwise we are not able to find more accurate Bitcoin price prediction. Because of that reason we applied that logic. Based on that we estimated AB values, and hence we will get the best fit regression line by substituting AB values. Now we will see one example. Let us assume this is a simple example. Bitcoin open price, I'm assuming like this, simple data, maybe some negative also there, no need to worry. So this is X value, this is Y value. X is nothing but BTC open, that means Bitcoin price open, opening price, and closing price, that is the closing price is nothing but Bitcoin price prediction value. Now X value is one independent variable, Y is dependent variable. We have to establish the relation between these two variables by using linear regression. There we are looking for AB value. So that means we have to find y equal to a plus bx, but we should know AB values. How to find AB values are given in the previous slide formulas, even derivation also. By using that we are going to calculate. Here you can see the formulas what we discussed. A formula we know, and B formulas are given. By using that we have calculated A value and B value, and N is nothing but number of observations. We have 6 observations, and substitute all the values, so that we'll get y equal to ax plus b. So y equal to 0.93x plus 0.38. This is the final regression model. How we got? By using the concept of sum of squares of error is minimum. Now we know direct formulas we can apply, there is no issue, but how we got that formulas is the concept what we applied for the graphical representation. Now substitute AB values and we'll get the final regression model, and based on that we can predict the future value. Now you can see, now this is the best fit regression line. Almost the data point, these are all data points what we applied to the previous problem, which are close to the regression line. You can't find better than this regression line which is close to all these data points. Suppose if I'm trying to like this, so some of the data points are far away from this regression line. If you find like this, or if you find like this, so this is a best fit regression line which will give more accurate results. Suppose if I want to find what is the value of y at x equal to 10, then you will get here. So maybe some value here. Let's assume 9 or 11 something. This is the 11. Substitute 10 in place of x. When you substitute 10, you will get y value. So that is the forecasting or prediction of the future value, or maybe weather forecasting or Bitcoin forecasting. Whatever regression model we got, in which we have to substitute x value, so that we'll get corresponding y value or dependent variable. So when you come to the Bitcoin price prediction, so this is the open price of the Bitcoin, and this is the actual Bitcoin price. Almost you can see the regression model this one, and almost all Bitcoin prices are very close. So maybe if you take 1 month data, let us assume, or maybe 1 year data, depends. Bitcoin price prediction, based on that we can predict the future value, that is future Bitcoin price prediction. So you can see this is the regression model, it is hidden. So this is the regression model. You can see all the data points, all the Bitcoin prices up to yesterday, let us assume, so are almost close to the regression model. By using that, today I can find what is the Bitcoin price prediction, that is closing price prediction, or maybe tomorrow I can predict by substituting x value. So this is the way we can find the regression model, and based on that we can go for predicting the Bitcoin price. Of course, here I'm taking one independent variable. Suppose if you have more than one independent, like open price and high price, low price, based on that, how to find the Bitcoin price prediction. That means if you have 3 independent variables, how to find. So we are going to apply same concept here also. So now we will see regression model evaluation. We know how to find the Bitcoin price prediction by using linear regression model. Of course, we will see multilinear regression also later. But the question is how to evaluate. So let us assume we have logarithmic regression, linear regression, exponential regression. Let us assume polynomial. So many regression models are available. But we discussed in to go for mean squared error, that is called MSE. By using that, we can identify how much error, and next one is R squared. So these are the two measures we are going to apply. Of course, so many other measures are also available, but these are the two basic measures. By using that, we can evaluate the performance of the regression model. So what are the formulas for these two? We'll discuss here. So MSE is, so here formula is Y value, let us assume this is the actual value, X value, I will give X value, Y value, Y cap is nothing but predicted value. Suppose X value 1, Y value 3, my predicted value is 2.5. X value 2, Y value 4, my predicted value is 3.9. So when you see the difference, when X equal to 1, Y cap difference is 0.25, that is the error. When you see second one, 4, 3.9, 0.1. So that means here actual value minus estimated value whole square. Why we have to make square, I already said. So sometimes negative error, positive error, when you make sum, it becomes 0. In that case, difficult to identify which model is the best. That's why we have to make square and make sum. That's why we are using sum here. All the errors we have to find. That's why we have to use sum divided by n, number of observations. So this is called mean square error. N indicates number of samples. If you take here in this data, number of samples 2. So X value 1, 2, that means number of samples 2. So MSE equal to 1 by n summation yi minus y cap whole square. Yi is actual value, y cap is predicted value or estimated value. So whenever low MSE, which indicates that the given model is more accurate. High MSE, which indicates that the given model is not that much accurate. So you can see here the error should be minimum. So whenever the error is minimum here, then MSE value is low. If the error is more, then MSE value is high. That means low MSE value indicates the best regression model. High MSE value indicates the not best fit regression model. So this is the way we can calculate MSE. So we have height, X value, Y value, estimated value. By using this regression model, we know how to calculate by using the formulas what we discussed. And finally, after calculating MSE is 6.08. So here I apply linear regression. Suppose if I apply exponential regression, my MSE value is, let us assume, 7.5. Then this is the best fit regression. Linear regression is the best when compared to the exponential. Suppose let us assume I am assuming logarithmic regression model. There I got MSE value is, let us assume, 4.0. Then this is the best fit because 4 is less than 7.5, 6.08. So that is the best fit regression model. So that's why MSE value we have to evaluate whatever models we apply to the given data set, and we have to look for at least MSE value that is the best model or that is the best fit model for the given data set for Bitcoin price prediction or any other applications. And we have one more measure that is called R squared, or we can call it as a coefficient of determination, in which the formula is correlation whole square. So correlation coefficient whole square. The correlation coefficient means it will establish the relation between X and Y. Suppose what is the meaning of correlation? If price increases, demand increases D, let us assume P. Whenever demand increases, price also increases. Whenever demand decreases, price also decreases. This we can call it as a correlated. Demand and price are correlated. So how to measure this correlation? For that we have to go for correlation coefficient. So that is the concept. So whenever we have demand values, price values, we have a data set. Let us assume 1000 records we have. Then if you want to measure the relation between these two, demand and price, find the correlation coefficient based on that. If the correlation coefficient is 0.9 value, then 90% similarity is there. If the correlation coefficient is 0.8, 80% similarity is there. If the correlation coefficient is 1, then 100% similarity between demand and price. That is the meaning of correlation coefficient. So here, whatever correlation coefficient we got, just we can make a square. So correlation coefficient formula is covariance of xy by standard deviation of x, standard deviation of y. That is the statistical formula. So just whatever correlation here, just make a square, rho square, or we can call it as a R square. So that is called R squared measure. So what is it indicates? Whenever R square value is, let us assume maximum is 1. So that means 100% the given model is best fit. That means how R square value will tell how the regression line predicts the actual values. So whenever R square is 1, which indicates that actual value, predicted value, both are same. If R square is 0.9, 90% similar. If R square value is 0.7, 70% is similar. That is the meaning of R square value. That means always R square value should be high. Maximum is 1, minimum is 0. 0 means there is no correlation. If 1 means 100% similarity is there. So you can see here, if I take R square equal to 100, you can see all the data points are touching the regression line. You can see this is the beauty of this R square. So R square equal to 1, 100% means 1. So all the data points touching the regression line, that's why we are getting this is the best regression model. No model will get more than this 100%, but that is the highest. So we can fit or we can fix for our application, or we can apply to the application. Suppose if we take second one, R square is 80%, that means 0.8. Some data points are touching the regression line, some data points are little bit away from the regression line. That's why we are getting 80%. Suppose if I take R square is 40%, you can see the data points are, most of the data points are a little bit away from the regression model. If 0% means none of the data point is close to the regression model, that's why R square is 0. That is the worst thing. When you look at this type of values, R square 0, suppose rainfall in Bangalore and number of COVID cases. Is there any relation between rainfall and COVID cases? If rainfall increases, whether COVID will increase, or rainfall decreases, whether COVID will decrease? No, there is no relation between rainfall and COVID cases. That's why we can call it as uncorrelation. So such scenarios will get R square equal to 0%. Now, what is the here you can see 0.988. Almost the data points are very close to the predicted regression model, and based on that we can, here R square is 0.02. Here also same scenario. The data points are very far from the regression model, predicted regression model. Now, what is the final conclusion? Whenever MSC value is low, there is a MSC value should be always low, and R square value should be high, then that is the best fit regression. So MSC value low means it indicates that the error is very simple, I mean very minimum. R square value high indicates that which is the best fit regression line for the given data set. So that's why MSC value should be always low and R square value should be always high. Suppose if I take here, if you take this data point here, high MSC, low R square value. Here low MSC and higher, because all the data points are very, very close to the regression model. Now let us assume I have a big data set and I have calculated MSC R square linear model RM1. I got MSC 0.45, 0.72 R square. 1 second. Sir, I'm in session, I'll call back. For first line, I got MSC square. MSC is 0.3, R is 0.95. Assuming we have a Bitcoin and I evaluated regression model, and after evaluating various and I applied 4 regression models and I evaluated MSC R square value for all regression models. Now we have to decide which is the best regression model and we can deploy to the application. Now we can see here, always look for low MSC. Low MSC means 0.23 is the low MSC here, 0.23, and high R square 0.95. So therefore we can say regression model 2 is the best fit regression model. So that's why we can go for prediction of Bitcoin prices in future by using regression model 2. That means we can deploy to the application. So this is the way we can evaluate the regression model for Bitcoin price prediction. Based on that, we can decide which model is the better or good based on the MSC R square. MSC value should be always low. That means error should be always low. R square should be always high. That means best fit. The data should be best fit with the regression model. I think evaluation is clear. So what is MSC, what is R square, how to calculate, and what is the conclusion for the given data set. Not only for Bitcoin price prediction, if we take any other data sets also, we are going to apply the same concept. Now I will show one case study how we are going to apply. Of course, I have shown one linear regression. We'll go for multi-regression model. So the data set, and the same thing I have shown initially also. Here, this is the Excel sheet downloaded from the website, open source only. Here date we have and symbol is not provided, and open price, close price, low price, high price. So first applying regression model, log column also not required for our data. In pre-processing we can neglect these columns. Now want to open, let us say 1,001, not low x2, high x3, and we are looking for closing price. That is Bitcoin price prediction. So we are looking for Y value, that is called close price. So Y, this is nothing but Y. Close is Y, is X, low is X, is X3. By using these three, we have to find the Y value. We have to look for future value. So date open means Bitcoin open price for take either day what also you can look for which time, depends on the application. Yeah, sorry, disconnected. Just a second, I'll share. Sir, can you see? Are you able to see my screen, sir? Whether my screen is visible?
Yes, sir. Yes, sir. Your screen is visible, sir.
Thank you, thank you, sir. Yeah, sorry, some network issue disconnected.
No.
Yeah, so here, these are the attributes explanation here for predicting the Bitcoin price prediction. So here we are going to apply multilinear regression model. So I already gave the formulas for linear regression. Same thing we have to apply here also. But only thing is here, number of independent variables are more than one. Here I am taking x1, x2. So b0, b1, b2 we have to calculate by using the formulas what we discussed in linear regression model. And after that we can estimate the regression model. So by using this regression model, of course it will take time to evaluate this b0, b1, b2 values, because we have to evaluate x1 square, x2 square, x1 y, so many values we have to calculate. After that we have to substitute, then we can find the y value, that is called estimated regression line. By using that we can find the value of x. So here, yeah, so here you can see the actual value, predicted value, almost very close. When you come to the regression model, the actual value, predicted value, you can see here. So based on that, we can easily find the future value also. So that let us assume tomorrow I want to find what is the Bitcoin price prediction, or maybe the day after tomorrow, depends on the day if you are looking, or maybe time also if you are looking. Based on the data set we can find. So this is one of the reference I consider predicting closing price of a Bitcoin using multiple regression. So here closing price is nothing but Bitcoin price prediction. So by using multiple regression, so the same data set here also, this author also assumed same data set: high, low, open, close price, and volume, market cap, name, symbol. BTC means Bitcoin. These things not required for us. So in pre-processing we can straight away ignore these columns. Even you can see here. So we will drop name variable. Secondly, we will drop symbol variable, like that. In pre-processing, suppose if we implement by using Python or R programming, we can drop these variables directly, not required. We have to keep only dependent variable and independent variable. So the algorithm or flowchart looks like this. So we have a data set, data training Bitcoin data set. Just now I have shown this is the Bitcoin data set what we are going to consider, or this is called cryptocurrencies historical prices. So this I have downloaded from the Kaggle repository. And Bitcoin data set, that is the flow chart, and data set training, let us assume 80% and 20%, whatever. Suppose if we have a data set with 100 records, that means last 100 days data we have. So 80 days we can take it as a training, 20 days we can consider for testing. And we can apply classification, either linear regression or multiple regression. Of course, we have decision trees, others also, and evaluate the accuracy. Just now I showed how to evaluate accuracy. We have to use MSE or square value based on that, and finally compare the result. Based on that we can decide which model is the best one. So basically what we are going to do, we have to take a data set, we have to divide training and testing, especially while implementing. This is very important. And after that we have to apply any classification technique, a regression model or maybe other models, and after that we have to evaluate the accuracy. Based on the results we can say which model is the best one. So here I have calculated y value by using the formulas what we discussed in the previous slide. This is the predicted variable y by using high, low, open. By using that, closing price is nothing but y. So when you come to the predicted value, almost close. 144 predicted is 140. 139, 136, 116, 118, a little bit close. So 4-5 difference is not a big issue. But if you have 140, 250 means that is a big issue. But here whatever actual values and predicted value almost close: 105, 109, 97, 94, 95, 112, 110, almost close. The closing price of the Bitcoin and the predicted Bitcoin price almost close. So this we can use for future Bitcoin price prediction. So here up to 25 days later we have, suppose if I want to find what is the Bitcoin price tomorrow, or maybe 27th day, like that. So if you want to find maybe coming 1 week, based on that we can go for decision making. So here the R square value is 0.923. That means almost 92% accurate. So the multiple regression model what we have evaluated for the given data set is 92% accurate. And this B value, X1, X2 coefficients we evaluated by using the formulas what we discussed in previous slide. So that formulas we have to apply directly, based on that we can get. And we know how we derive that formulas also, the concept we discussed. Suppose if we implemented by using R programming, you can find here, so the R square value 0.99, adjacent R square value, adjusted R square value, and we can find the other things also, whatever parameters, all those things we can find while implementing this in R programming. But of course we are not taking R programming due to lack of time. And you can see here the regression models for closing price for given high price or low price or open price. Almost all the cases, the closing price is very close to the actual price. And when you take independent variable as high, low, and open, so you can see all the data points are touching our regression model. All the data points are touching our predicted regression model. So which indicates that the regression model giving more accurate, because we already got R square value is 92%. So 92% is very good. So the actual value, predicted value almost close. Based on that, we can predict the future value. That means we can predict the Bitcoin price. And here, let us assume the training data, up to training data. This is a testing data Bitcoin price prediction. So now the conclusion is, so that means the Bitcoin prediction conclusion is, so based on this, suppose if you want to find the Bitcoin price prediction tomorrow, or maybe day after tomorrow, maybe coming 1 week, we can apply the model, and based on that we can predict the value.
Sir, excuse me, sir.
Yeah.
Sir, your screen is not moving, I think. Are you on the, like, there is a diagram, great, good, okay, and inconsistent?
Oh, still you are in that
Is it?
screen? No?
Yeah, we are on
Moving,
that
sir.
screen only.
Now I am showing A in finance, like that one screen I'm showing.
No, but
While
we
explaining,
can
I'm
see
moving
your,
one by
the
one.
previous slide, I think, where were you were before the break, yes. It is not moving.
1 second, sir. 1 second, I'll stop again, I will share. I'm trying to share once again, sir.
Yes, yes, yes.
So, are you able to see, sir, my screen?
We are still on that screen only.
Now I'm sharing high, low, open, close, that one. Now I move to next slide. There R square one watch is there. Are you able to see?
So we are on the screen where the 4 diagrams are there, and comparative R squared and different linear models. We are on that
yeah,
screen.
that one. Correct.
Yeah.
Coefficient
So,
B, X1, X2, X3. Yeah, correct on this.
yeah, you can check to like by moving the slide.
Now it's fine, sir. I think. Yeah. Now fine, sir. I think. Now can you see 3 diagrams, sir? Like high, low, open.
No, sir.
3 graphical representations.
Maybe you need to reshare your screen. Just
Again, I stopped. Again, I shared, sir.
yeah, you need to stop the sharing and then reshare again. I think there are
Sir,
some.
can you read out? Sir? Can you read out in which slide I am? According to you.
Yeah, we can see your slide at comparative comparison of R squared for different linear models. It's
still
R
you are
square
in that.
100%, R square 80%. There are 4 graphs. R square 0%.
Oh, there is still you are there now. Okay, sir. I will stop once again. I don't know what. Yes.
So maybe you need to withdraw the screen first, then it will work. You can try it.
So are you able to see my screen, sir?
So can you? No, sir. No, sir. We are still on that screen.
No, I with it on everything I left again. I joined.
Your screen is still
No, from my
present.
side, everything is closed.
Like oh, so, or
Well, everything is closed.
Maybe somehow it is your slide is like I don't know how it is freeze at one place. So maybe you can try by left yourself and then rejoin the meeting. Just you can try if it will work. Leave the meeting and then rejoin with the same link.
Joined once. Now, can you see my new screen, sir?
No, sir. No, sir.
I left the meeting again. I have joined. Now I'm sharing my screen actually.
No, sir. You are still there in the meeting. You have not left yet.
No. I left again. I have joined. Now I'm not sharing anything. Just I hold my sharing also everything.
Sir,
Madam?
yes, sir. What you are saying is correct. We can see a blank screen. We cannot
Correct,
see
madam.
anything. Okay.
Correct. That's why I'm
So,
getting.
sir, I would request that other participants should actually rejoin the meeting. Then the screen will move. Because I was able to see all the screens that you were showing, all your slides.
Okay. Now you can see my desktop now, madam.
No, sir, not yet. I'll just.
And now again I'm sharing.
Okay. I'll just. No, sir.
Still
Yes, sir.
processing.
I can see your desktop, sir. But we need to rejoin for this, sir.
Yeah.
I can see your desktop.
Are you able to see my screen, madam, now?
Yes, sir. Yes, sir. I am
Yeah.
able to see the screen. But I think we all need to rejoin for this.
I think there is a technical issue because I can.
Naveen, sir, I think you can leave the meeting and try rejoining, sir. That's how I am able to see everything.
Okay. Let me check.
Yes, sir.
Madam, my screen is visible now. High, low, open, close, like that.
Yes, sir. Yes, sir. I can see.
Issue from I think SAR side also.
Now, sir, again, nothing is visible.
No. Still it's loading, madam. Loading.
Okay. Yeah.
Now I think you can see, madam.
Yes, sir. I can see all your high, low, open, close.
Oh yes, madam. 5 minutes. 5 to 10. properly now?
No, sir. I have rejoined, but have you shared your screen?
Yeah, I already shared, sir. Madam also able to see.
Okay, but
This Microsoft Teams, I don't know, sometimes like this only.
maybe Microsoft Teams.
Because Google Meet means there's no issue
Now
for
I can.
them.
Right.
No, sir, I am viewing it on Microsoft Teams only.
Yeah. No, in general, this is some issues are there sometimes. Naveen sir, is it okay for you now? Is it?
Sir, I can see your blank screen, but not, I don't know why it is showing like this.
What happened? Suddenly, initially everything is fine.
So I think there's some other issue because I can again see you just change the screen, right? Y equals to 20 point something,
Yeah, correct, man. Correct, man. That one.
right? And you
Yes,
now again change the screen model equals to sm.formula.os. You have
Yeah,
done the
what you
OLS
said.
integration
Correct,
results.
man. This is
Yeah,
correct.
so I am, yes, sir. So I am able to see the screens.